Hi, welcome back to the Section Vedi channel. And in the past video, we discussed about a lot of things, and it's very crazy things. So if you don't watch, just watch it before you can see this. Okay, so let's start. So in this video, we discuss about event ordering and consistency models. So first, understand what is event ordering. So when you perform any activity from the server, it terms at events that is passed, like event B, event A, event C, and in the order that these events are passed is called ordering. Okay, so in this context, these are termed as a event ordering. Okay, so there are different type of event ordering are in the scenario. So suppose first one is the total ordering. In the total ordering, in the total ordering, there is a global rule set that, or the in the way the event are passed, it is in the same way must be all the event have to pass. So suppose server A pass first B first, then A first, then C first. So it will create a particular global file, and it will indicate to all the servers to do the same thing to all the users who is asking the data from different server. So all the servers now will give you first B, then A, then C. First B, then A, then C. So in that total ordering, you have to first know one thing, that the order is always same. Just one thing, order is always same. Suppose you have a one person Alice, and Alice sent a message, hey, how are you? And Bob replied, I am fine. So every server should, if Bob didn't reply and Bob sent like, hey, how is your home? So these are the two different messages, but still every server should say A first, then B, A first, then B, A first, then B. So this is the total ordering, means every message in a same way, same ordering. Like banking system use that, your stock markets use that system. Of course, stock market must use this system. Otherwise, anyone can profit and anyone can lose. Now, let's move forward to our another ordering system, which is a partial ordering system. In the partial ordering system, things are little change. Partial ordering system says that, okay, you can do, as you can see the name partial ordering means, it can say, it's saying that, okay, you can do one thing for few things we can allocate a kind of order, but few thing which is independent of this can be done in any way. Okay, like we have A B C. So A B have some relationship, but C have not. So we can write like this, CAB. We can like this also, ABC. Okay, like suppose like suppose, if we have an example of Alice ask, hey, how are you? Bob replied, fine. And then John messaged, I am back. So if you see Alice and Bob have some relationship and John do not. So we can say, okay, server will put like this, Alice, Bob must be have in a same zone, but John can be put either this or from this. Okay, so this is the partial ordering, means some is ordered, some is not. And it is also important in the case of payment processing. Suppose you are ordering a item and you go on a payment page. Now you do not want all the user on the system want to see the payment page at that moment. So in for you this event is, it's a kind of example, I think it's not good example, but it's a casual ordering for you. Now let's a good example of git branch. Git branch is a very good example of casual ordering. So I'm sorry, partial ordering. So in the case of git, if you see, if you have c1, c2 and c3 and c4, so you create a new branch from c2 and a new branch from c2 to c3 and c2 to c4. Got it? Got my point? So any developer can write like this: c1 to c2, then just give me a moment, then c3, then c4, and he can also like this: c1 to c2, then c4, then c3. So he can write like this is also correct and this is also correct. So git commit is a good example of partial ordering. So it is partial ordered, this thing is ordered and this thing is not. So thing is partial ordered. Now let's move to casual ordering. In the case of casual ordering, it's kinda cause and effect. You have to know one term: cause and effect. Okay, so it's depend upon the situation and its effect, and on that behalf it ordered the things. So suppose suppose Alice and Mike, these are the two person, and they message at the same time, let's meet at 5 p.m. and I love coffee. And Bob replied, can't come. On which message? Suppose on this, let's meet at 5 p.m. message, he replied, can't come. So what is the cause? It is the cause of Alice message that Bob replied. Okay, but at at the same moment, Mike also messaged, I love coffee. At the same moment, Mike also messaged, I love coffee. So it may be first I love coffee print, then let's meet at 5 p.m., then it can't come print. So but can't come is fixed because it is the cause of these two. It is a reply of these two. Suppose you message, hey, how are you? Then its reply is fine. So fine never print first because fine is the cause of this message. So in casual relationship, you have to know one thing: it is the outcome. It is the outcome of previous, you can say, event. So cause and effect, you have to know this thing. So we see there are three type of ordering in system design. Is like, first is total ordering, in which all event are must be in a same way to by the all the users and all the servers. Then is like partial, in which some kind of ordered it partial, some kind of event is ordered and sometimes some type of event is not. And the third is cause casual relationship. Casual order means it have a dependency on one event, and it is a kind of cause and effect relationship it have. like, hey, how are you? Then I am fine. So in that context, it works. So we have three ordering mechanism, and in that way the event is passed and sent to server to the client. And if we have multiples, these topics are the part of distribution system design. So if we have a different kind of server, S1, S2 and S3, and client can ask the data from any of the server. He doesn't know you have a cluster of servers. You have to give the correct data to your customer. It's your job to design that system. That's why we are learning system design. Okay, thanks for watching. In the next video, we discuss about database replicas, like how we can design the database so he can scale and fault tolerant, and like data will be replicated properly in all the DBs very well. Okay, thanks for watching. Keep like and keep subscribe my video. Bye bye.